Hi and welcome to 24 Hours of Past. This is the 24th session, so it's the very last one. My name is Rob Farley. I'm your moderator tonight. I say tonight because it's 8:30 p.m. where I am in Adelaide, Australia. But wherever you are and how many of the sessions you've attended so far, I hope you're having a good time and that you're awake still. I feel for Vicky from Past, who's been on just about all the sessions so far, and she must be absolutely exhausted. So also on the call is Brian Mitchell, our speaker. He's going to be talking about the role of PolyBase in the modern data warehouse, and it's going to be a fantastic session. He's going to cover the topic for about 3/4 of an hour, and then we'll have time at the end for any questions and so on from those of you who are still surviving the 24th of this fantastic event. Just a couple of quick technical things. In case you haven't been on any of the other sessions, if you do need help with anything, and I'll quickly ask Brian to change the slide. There we go. If you need help, then please look in the GoToWebinar panel where you can see a button to be able to raise your hand. If you do that, then I'll start a little conversation with you, and we can figure out what's going on, and so on. And if you can't hear me, then there's no point in me reading any of this out to you, but hopefully you're already calling at me to be able to say that you've got technical problems, including audio things. Feel free to maximize the screen. You can, when there's demos and so on, if you're having trouble seeing anything, then that can definitely help. And feel free to type questions into the panel. It's a fantastic way of being able to see what's going on. Now, Brian at the end will be able to go through a lot of those questions, and I may read some out depending on how we go with that. I've already heard from Dinesh that he's on his 4th Red Bull for the session, so that's fantastic. A massive thanks to our main sponsor, Microsoft. Not only have they been able to provide heaps of people from the product group and consulting services and so on to be able to really give in-depth, up-to-date information here on this SQL 2014 dedicated 24 Hours of Past. But they're a fantastic support, of course, for Past in general. They're one of our founding companies. They continue to have people on the board and are a tremendous help to the overall SQL Server community, of course. I want to mention to you about the Past Summit. Now, if you've never been to the Past Summit before, oh my goodness, you so need to go to this event. It's not only the largest SQL Server event anywhere in the world every year, but it really is a must-see event where you get every SQL Server expert in the world just about turning up and giving presentations. People honestly travel to this place from every continent, just about. And I don't think we've had anyone from Antarctica yet, but I think many people live there. But all the populated continents, people go and present, and you get to be able to hear all kinds of different sessions, and even just the networking is fantastic. Make sure you get to it this year. Now the current price is $15.95 US. That goes up this weekend, so make sure that you register soon. And if you talk to your local SQL Server user group chapter leader, then they'll be able to give you a code to get a further $150 off your registration. And furthermore, there's benefits for the chapter from you doing that. So if you are going to register, please say which chapter you're from, use the code, and there's additional benefits for the chapter if you do that. But it does go up by $300 this week. So please get talking to your boss and get that sorted. I don't want to say too much about our speaker because he's about to jump in and he'll be able to explain who he is as well. But suffice to say, Brian Mitchell is one of the big data experts. He's a senior consultant in the Center of Expertise. I was going to say Center of Excellence, but it's actually Center of Expertise. He's based down in Florida, and he's a regular around the PDW speaking circuit, and he's going to speak to us today about PolyBase. I'm going to go mute, so I'm going to hand over to Brian now. Thank you very much. Wherever you are, be clapping. We won't be able to hear you, but clap anyway for Brian as he joins us. Thank you, Brian.
Thanks, Rob. I appreciate it. So I'm going to jump in pretty quickly. I got quite a bit of material to do over the course of 45 minutes, and I'll try to bring some energy. It might be 8:30 at night where Rob is, but it's 7 in the morning where I am. So Today I'm going to talk about the role of PolyBase in the modern data warehouse. I've been working with PDW pretty much since day one, as I was one of the first engineers to work on the product in the field, and worked on it in multiple customers as a consultant and an architect over the last few years. And so I feel pretty comfortable talking around the discussion around the APS system, PDW, HDInsight. Those are where I usually spend most of my time. And today we're going to speak specifically more about some of the technology behind PolyBase, and then where I believe that customers can leverage it in their environments. So the program today, we're going to talk a little bit about the basics of PolyBase. Definitely talk about some of the scenarios. Some of those scenarios listed here, like Hadoop for staging, bringing in some ambient data from Hadoop, exporting your dimensions out to Hadoop, and using Hadoop as a data archive. I'm going to save the demos for the end and probably just do one all-up demo so that you can kind of see how it all is brought together due to the constraints on time. So let's talk a little bit about the traditional data warehouse. You might have seen this slide before, and it's really talking about how data warehousing has really reached a tipping point in and of the fact that they are getting larger and larger to the point where your traditional relational data management system is having a harder and harder time dealing with the amount of data and the types of data that are coming in your traditional data warehouses. And that stress is putting a stress on our data warehouse that sits in between where we bring a lot of ETL into it and where we need to do a lot of BI and analytics on top of it. And so if you look at it, some of those stresses are increasing data volumes. There's more and more data volumes coming in our data warehouses, not only because we have more sources, but we've decided on bringing in sources that are much more created by machines, for example, in nature than created by humans. And anything that's created by machines tends to grow much faster than what's created by humans. For example, log files coming from multiple web servers, for example, can generate a ton of data in a way that a bunch of people sitting at keyboards or point-of-sale systems just can't do. So we have increasing data volumes. We have a need for real-time data from the BI and analytics, and you hear this all the time, which is I need more real-ish time data for my analytics. I can't wait a week, I can't wait a day, I don't even want to wait an hour. I pretty much want it to be almost up to date all the time. So that causes problems for us. And then, of course, we have the new data sources and types. Talk a little bit about that, like data coming from the web. You also have devices and sensors and social data coming in. And some of the structures from some of that non-relational data becomes problematic trying to get it into the data warehouse. The ETL, using traditional tools that we have, can get bottlenecked very quickly trying to deal with JSON data, for example, and pushing that amount of data into your data warehouse with that structured data. And then, of course, we have the cloud-borne data sitting out there. So there's lots of cloud-borne data out there that we're trying to bring in, and that's putting additional stressors on our data warehouse. So the idea of having one box that's called our data warehouse and everything going into it has become more and more problematic as we try to bring all this data in. So Microsoft has really kind of defined what we define as the modern data warehouse, and that we are really more talking about kind of expanding that over into more of a virtual data warehouse where we have multiple data management processing systems, not just one ETL system, but multiple ways to deal with that data as we bring it in. So we have relational and non-relational data. Of course, we have analytic data that we might want to deal with, and we have multiple ways to data enrich and federate that data. So there's more we can either and bringing all that in eventually gives us our BI and analytics that we're able to do. And of course, you've seen over the course of the last couple of years, Microsoft giving many more tools to the analytics community to deal with their analytics. So you have many more choices there also. And we're going to spend most of our time down here at this orange level, the data management processing level going forward. So try to click through the next screen. All right, so what we have here is we're really thinking about more of how can we bring things like for enterprise-ready big data, how can we bring Hadoop and SQL Server together to be able to solve our problems? So we have relational and non-relational data in a single appliance in PDW, or the APS system, the Analytics Platform System. So That allows us to have enterprise-ready Hadoop sitting side by side your data warehouse, your SQL Server data warehouse tools such as PDW, which allows us to integrate querying across the two using straightforward SQL. We also need to do performance at scale, and what that means is that APS allows us to now do the in-memory column store, so the cluster column stores that we get with SQL 2014. We've actually had with the PDW appliance for about 1.5 years now, and that allows us to do some of that near real-time performance that's needed for the BI side as we load data into our cluster column store environments. Also, we're able to scale out and accommodate growing data. We can scale out both the PDW region and also the Hadoop region by simply adding nodes and scaling out as necessary. And what that does is that removes some of our data warehouse bottlenecks within PP SQL Server over a typical SMP environment. And then we can also get engineer profitable value. It's the industry's lowest data warehouse appliance price per terabyte. You get all that value through a single appliance solution. And of course, you have flexible hardware through our multiple partners. And some of those partners you see on this next screen, as we talk about Dell and HP and Quanta, really allow you to get some of those plug-and-play environments going. So on the left side, you can see the analytic platform system, and we have different regions for that system. We have the traditional SQL Server parallel data warehouse, which we've had out for about 4 years now. It's at version 2, AU1. And now we have this new Microsoft HDInsight region, which is our Hadoop region inside the appliance that you can add on to your analytics platform system. And what we're going to be speaking about mostly today is PolyBase, which is really that solution that sits in between the two that allows you to move data back and forth between the two systems using traditional T-SQL that you've known, loved, learned over the years. And we're going to speak really in detail about that. Before we do, let's talk a little bit about the HDInsight region in PDW and what that can do for you. So what it allows you to do is really, it gives you 100% Apache Hadoop environment. In fact, it's HDInsight based off Hortonworks Data Platform 1.3 at this point. And so you know you're getting 100% Apache Hadoop, which means anything you do inside of Microsoft HDInsight, you could translate out into another Apache Hadoop environment if necessary. So the Hive QL or the PIG scripts that you write within Microsoft HDInsight, if you wanted to move those off to somewhere else, you certainly could. We're going to talk a lot more about leveraging how you can leverage PolyBase to do a lot of those things in this particular discussion. So also what it also gives you is it also gives you end user authentication with Active Directory. You can monitor it with System Center, Operations Manager, and also it gives you also the accessible insights for everyone with your BI tools because you can use your traditional Microsoft BI against it. A little bit different look at it as you look at the appliance. As you have these different regions, you have the PDW workload, you have your HDInsight workload. You also have what we call the fabric, which sits on top of the hardware, and the fabric is just essentially the layer update, the layer of solutions in there that includes the networking, the host systems that run the VMs that PDW and HDInsight run on, and all the other stuff that really makes the appliance work while the VMs of PDW and HDInsight work on it. It provides you the security and servicing that you need. All right, so the overview at a high level is that it's HDInsight running on the appliance as a workload. It's HTTP 1.3, as I said. What it provides for you is the ability to add on HDI to PDW so that you can run Hadoop next to PDW. And I'll talk in length about what that means for you in just a minute. What's included is HDFS. You get MapReduce with Hive and Pig. You can also run Oozie and WebHCat, and of course you have Hive ODBC and Scoop for data integration. But mostly what we're going to talk about is how we use PolyBase for that integration. And here are some of the hardware topology. If you really want to look at it at a hardware standpoint, what you'd see if you've got the minimum PDW rack, which is a quarter PDW rack with a quarter HDInsight rack, this is what your hardware would look like with a couple IB switches, a couple Ethernet switches. You have your PDW control nodes, your HDInsight head nodes, And then you also have your data nodes and your storage spaces down below for both PDW and HDInsight. All right, so connecting some of the islands of data with PolyBase. So if we have all that, you bought a PDW, you have your HDInsight, or if you just bought a PDW and you have your own Hadoop region, you can also use PolyBase. But the idea here is that we can use PDW and PolyBase to talk to HDInsight and really connect it. So PolyBase is there to connect these islands of data that are sitting out there so that you have a single T-SQL query model for PDW. It uses the power of MPP to enhance your query execution performance, and it provides the ability to query non-Microsoft Hadoop distributions also. So what you see there is we could use PolyBase to talk to Microsoft HDInsight internally to our clients, but we can also use PolyBase to talk to Hortonworks for Windows and Linux. We can also talk to Cloudera environments. We can also talk to Microsoft Azure HDInsight environments. So the idea there is no matter where your Hadoop environment is, but those pretty much cover about 90%, 95% of the Hadoop environments out there. What this allows you to do is really kind of cover everything that you might need to do with Hadoop through PolyBase to bring data into your PDW appliance. So let's talk about PolyBase and what that really means for us. And what PolyBase is the ability to essentially query any data in any location in any format. That's really the goal of PolyBase. And we do that by starting off with this concept of external tables. We want to be able to basically data that's sitting outside of our appliance, sitting outside of PDW, that's sitting on disk somewhere. We want to be able to define that data source, basically point at it and say, hey, there's some data over here we want to get. We want to define the file format, or in other words, apply the metadata over that data source, and then apply an external table over that. So the idea that we can then access that data. So if that data source is HDInsight in your appliance, what we're going to do is we're going to define that data source as HDInsight in our appliance. Then within that file, it's going to have some sort of structure. So we're dealing with semi-structured data here, or structured data, typically speaking, in that it has some sort of format. Even if it's a log file, log files have format, and we define that format over it with this external file format. And then once we've done that, we can define external tables over it. And once we define the external table over it, now that data to every other end user of PDW looks just the same as any other table that is within my appliance. So the concept of external tables, data sources, and file formats kind of looks like this. As we have our data scientists or BI users or database administrators out there accessing our PDW appliance, basically they're going to access that external table. Select star from fact sales, for example. And what we're doing underneath the hood is we've defined our data source and our file format to go out to in a Hadoop environment like Hortonworks or Cloudera to get that data and bring it back in. And PolyBase underneath there, the PolyBase query engine is really what is really driving all of that magic behind the scenes. It is translating all that data sitting in Hadoop into that PDW format, and it's bringing that data back into PDW in parallel. So what we're doing there is we're going through the process of it. First of all, we need to define our external data sources. And first thing you do is you create an external data source, and you basically define it of a type. And right now, the type we have is Hadoop, but in the future, there may be other types of data that's out there. And then we define a location. In other words, we define the location of our Hadoop appliance, and usually that's some sort of IP address. And then once we've done that, we can also enable tell it our job tracker location, and that enables or disables, or that enables the MapReduce job generation. I'll talk a little bit about that in a little bit. So once we defined our external data source, we can then define our external file format. In this case, we can go through and we're representing the external file format. We're going to store that in PDW, in the database that we're working in, and that defines the metadata of the data sitting outside of our appliance. So it's the same kind of basic concept of that you're used to in Hadoop, and we don't care when you're storing the data what the file format is. We'll simply apply the file format afterwards. So it is definitely schema on read. You can write the data all day long, and we can define the file format with the schema later on. And then we can go through the process of telling whether it has data compression or whether or not there's any format options. So some of those, and then you have the external tables here. So that's a file format, and then we can define an external table. So I define an external table, and that really just kind of goes out and defines what that table looks like. And I'll show you some examples here in a little bit, and that'll make a little more sense. And support of additional HDFS file formats with the current AU1 release of PDW includes Hive RCFiles, which allows us to deal with some compressed files also. Format options for delimited text files are here, and what you can see here is you can define things like delimiters and in-date formats for your data. So let's talk a little bit about the HDFS bridge, and that is the ability for, on the right side you see PDW with our traditional relational data. Our users are now querying PDW, and what they're doing is as they hit that external table, that allows them through the data source and the file format to hit the PDW engine. And if we're hitting an external table, it's going to go down to the HDFS bridge, which then goes and allows us to communicate with Hadoop. That HDFS bridge is really important because that is a parallel connection between PDW and Hadoop. If you have 10 nodes in PDW and you have 20 nodes in Hadoop, you have 200 connections between the two that are sitting there ready to move data back and forth. It is a fully parallelized data movement between the two systems, which is really important to the performance that you're going to see using PolyBase to move data very efficiently. All right, so querying external data, Hadoop data via T-SQL, and this is where we really start talking about some of the solutions or the kind of concepts of where I start seeing PolyBase can be very efficient with bringing data over to PDW. So let's talk about querying this data. First of all, you need to understand that we are doing predicate pushdown, where it's possible to do predicate pushdown, which significantly reduces data movement between Hadoop and PDW. When we're dealing with data sitting in Hadoop, we're often dealing with terabytes and terabytes of data. And the last thing that you want to do when you're dealing with that amount of data is have to bring it all over to PDW to be able to do anything with it. And so what predicate pushdown essentially means is that we're reducing the number of rows moved or reducing the number of columns based on the operators and expressions that you have in your queries to only bring back the data that we need. So what I mean by that is typically in a typical large table, you have lots, like I said, you have lots of terabytes of data, but you also lots of times have lots of columns of data. Although a lot of Hadoop environments I see literally have hundreds of columns in data. I just looked at one at a customer a couple weeks ago where they had 600 columns of data, but in any given query, they're probably only dealing with 10 or 15 of them. So you definitely want to be able to reduce that down. And so what we do with predicate pushdown is, as we push that T-SQL over to Hadoop, we are calling MapReduce if you are using predicate pushdown. And that MapReduce will reduce the amount of rows, it'll reduce the number of columns, hopefully reduce that traffic jam so that we're bringing back only the data that we need in order to do a query or a join moving forward into the next part of the query. So querying Hadoop data via T-SQL is really straightforward in that we are literally going to, first of all, create an external table for our Hadoop environment, and then we can do, PolyBase queries. So if I create an external table, I could then go do a PolyBase query where I'm doing a select 10, top 10 from clickstream where user IP equals something, and I'm going to then filter the data such that I'm only bringing back data where user IP equals 192.168.1. So that is a point where we're going to probably do predicate pushdown and run a MapReduce job to only bring back the data we need. That's really important for performance. And you can see a couple other examples of other data. And down at the bottom, you can see where we're joining data from HDFS with data in PDW, such that we are, so you can definitely see the advantage of that. And I'll talk a little bit more about that in a minute. So split-based query execution through PolyBase. What we mean by that is that we're able to, at a high level, we're pushing, when you run the query, it goes through the PolyBase query engine and it makes a decision. That decision is, do I just go get the data off disk and bring it back to PDW, or do I submit a MapReduce job? And really, the whole concept of that decision is how much data am I dealing with? And like SQL Server, to make really good decisions about whether or not I should either do MapReduce or just go get the data, we need to know a little bit about the data before we can do that. And so what we do is, when we bring this out a little bit, is we run that distributed query plan. When it's created, goes to SQL Server on the control node and basically asks, tell me the information about this table that's sitting out in Hadoop, so that I can decide whether or not I want to do data directly off of HDFS, or do I want to submit a MapReduce job. As you can guess, we get that data on the SQL Server control node by creating statistics over that external table. So just like everything else that you may have heard or do in PDW, statistics are very, very important in PDW. They're as important as typically creating, indexes in standard SQL Server. We need statistics so that we can make really good decisions. And even with external tables in Hadoop, we need to make good decisions using statistics, and the cost-based decision is done through statistics. So we store those statistics on SQL Server. Now when I do a query of that external table out there, I can go ahead and refer to those statistics and make a decision. Do I need to submit a MapReduce job, or can I get the data off disk? So that cardinality really absolutely matters. And the idea there is, we're not going to consider pushdown for inputs that result in less than a gigabyte per PDW distribution. If you know PDW very well at all, you know that there's 8 distributions on each node. So let's say you have 8 nodes in your one rack SQL Server appliance, PDW appliance. You're going to have 64 distributions, which means for that typical environment, if it's less than 64 gigs, we're not going to consider predicate pushdown at all. If it's greater than 64 gigs, depending on what the statistics say, we're going to consider it depending on the query, so that we can go ahead and bring the data back directly, or do predicate pushdown. And a little bit more about predicate pushdown here in the cost-based decision. Joins in general are always executed on APS, so we're going to do some of the pushdowns of the predicate on the external side. So if you have an external table and you're doing some filtering on it, we'll try to push down those predicates. But eventually we'll need to bring that data over to PDW and join that to the internal appliance if you're doing a join. So that tells you a little bit about that. Supported configurations for AU1, we can support HDInsight on the APS system. We can also support HDInsight Azure Blob Storage. We also have Hortonworks on Windows Server, HTTP 1.3 and 2.0. So PolyBase does support Hortonworks 2.0, and also Hortonworks on Linux and Cloudera on Linux CDH 4.3. So a lot of different support configurations. That covers most customers. And that allows us to basically start dealing with this. So let's start dealing with why. What can we do with it? So we talked a little bit about the traditional modern data warehouse being under pressure, with lots of data coming in and lots of data growing. So it's getting more and more difficult to push everything that you want into your traditional data warehouse. And so what that allows us to really do is question, why do we want PolyBase? And so we have this PDW appliance, and it's sitting there, and we've rolled it out, and maybe we have several nodes in there, however many nodes you have sitting there running your NPP appliance, and that's working all great. But you really have all this other data that's coming in, or data that you want to keep. And so what you're having to do is you're having to archive data off of it, or you're having to not bring some data in. You have to pick and choose what comes in your PDW appliance, and that becomes more and more problematic. What PolyBase does is it allows it to be bigger on the inside. And so that's really the way I think about it. You walk into the TARDIS and it's this little small box, but it's huge on the inside. And that's really how I think about how PolyBase can help us out here. And what that does for us is it really allows us to move into this emerging data architecture of the modern data warehouse, where now you have all these existing emerging sources coming in. I have my MPP appliance sitting over there on the left. I have Hadoop sitting over there on the right, and I can bridge the two together with that PolyBase sitting in the middle. And it really allows my system to really kind of emerge into a larger data warehouse. So what that means for us is, for a typical Microsoft data warehouse environment, as I'm bringing some of that data in, some of those emerging sources, I can store those in HDInsight, and I can do some of my ETL processing there on HDInsight before I move data into my data warehouse. This is really kind of an important emerging architecture that you're starting to see. One of the things you'll notice about ETL as you're dealing with it over time is that the larger your data gets and the more diverse your data gets, a lot of times it's not so much your data warehouse that has the bottleneck, but sometimes it's your ETL processing. Doing ETL in parallel, whether or not that's in PDW or whether or not that's in HDInsight, really opens up the ability to handle more different kinds of data. And HDInsight, with either doing it in Hive or doing it in PolyBase or doing it in Pig, is a great tool for dealing with ETL. Pig, in particular, is a great ETL tool that really allows you to deal with data, structure it differently, and really kind of set it up for your data warehouse. So this is where we start talking a little bit about how we can deal with some of those solutions. First of all, let's talk about using Hadoop for staging. Think of your typical Kimball data warehouse, where Kimball has talked a long time about how you deal with bringing data into your data warehouse and never deleting it. So you have your staging data sitting in staging, and you don't delete it because you never know when you'll need to recreate your final data warehouse. So in your typical methodology, you usually have a staging database sitting in on your appliance, and you also have your end user database sitting on your appliance, and you bring that data in. But the problem there is you have a couple problems. One, ETL processing becomes more and more difficult over time. I talked a little bit about that, especially as your data sources start changing. That really puts some pressure on your data warehouse because you're bringing all this more data in. You have to keep it in staging. Your data warehouse starts exploding, and it becomes more and more problematic. So we really want to continue to keep with the Kimball methodology of keeping our original data in our staging database, because it's really important that we might either want to recreate our final database, or we may want to bring new data from that staging database or find new insights from it. What we could do there is really start thinking about, with long-term data, raw data archiving, is really kind of keeping that data sitting in Hadoop. The idea there is all that data as it comes in, we can land it in Hadoop on our different nodes. We can use something like Pig to process it and move it over into a staging database sitting in Hadoop. And then we can use PolyBase to bring that data into our final tables over in PDW. What I'm proposing here is you use Hadoop for your staging environment, and you only use PDW for your final data analysis. And what the PolyBase allows us to do is really make that work so that all the code that we were using to move data back and forth between staging and our final database most likely can be very easily transformed into using the same kind of code that we would do for this environment. In other words, we just extended our data warehouse off of our PDW appliance into our Hadoop region, where the cost of storage is much lower, the ability to deal with ETL may be higher as our data sources change over time or get larger, and it really kind of just really deals with the data archiving in a very elegant way. Also, what it allows us to do is transform our data fairly efficiently. So the ability to transform that data on the Hadoop side very efficiently is really good. So things like JSON, XML, text, as we land those into Hadoop, we can use something like Pig again to transform that data and then land it into essentially tables sitting in Hadoop, which we can use PolyBase to bring that data over in parallel over to PDW. So how do we go about doing that? Well, first of all, we can create external tables. And so when you create an external table in PDW, the top part looks the same as you've always been used to. You create an external table, and then the bottom part is you provide a location. We've already defined the location of Hadoop with the data source. We've already defined the file format, and we say what it is, and then we tell it within Hadoop our location for this particular table is wherever it happens to be. So we create an external table, and then we can reference that external table in select statements. Oops, I did not mean to click that forward. I apologize. Going back one. So in this case, this is doing a simple create table as select statement. So this is now creating a table within PDW, referencing that external table clickstream that I had down below. So now I brought this query here is bringing data in from Hadoop into PDW, for example. All right, so we can also use PolyBase to export from PDW to Hadoop. So what I'm talking about there is the opportunity to possibly export conformed dimensions to Hadoop from PDW. So the idea here is you've done all this work over time to across your enterprise the conformed dimensions, and probably you're using your data warehouse to really kind of handle those conformed dimensions. In that, you have your fact sales out there, but you work really hard to conform customer and date and product and account such that everybody can, really use one definition of those things. The idea here is that PolyBase is actually a really good opportunity also to export these conformed dimensions out into your Hadoop environment so that your data scientists who may be working on something like back sales history and aren't using PDW directly can reference that information also. And this is kind of important also for those people to be able to do that. So now that they're using the same customer and account and data information product, they don't have to recreate it from scratch. You can simply use PolyBase to just create external tables out there and move that data out there for them to use in a very efficient manner. You can also use exporting of data to data archive data. And the idea here is that typically over time, what we've been doing as we archive data is, as we deal with data, it's becoming more and more difficult to deal with large amounts of data, and eventually we start throwing data out, right? We either start deleting it or moving it out to tape or archive it off into some other SAN, or archive it out to the cloud. That's one way to do it, but it's not the most efficient way, because what if you need to use it again? Hadoop is a great way to start archiving some of your old data so that you can still have access to it. So the idea here is that you have this data, you brought it all into PDW so that you can run OLAP cubes and people can do investigative analytics on it. But as you start filling up your PDW appliance, you don't want to expand it, you're not ready for that. And in fact, some of that older data people are querying very rarely. The idea here is you can use PolyBase to archive that data off into Hadoop. People can still access it when they need to. It's sitting off in low-cost storage. You can use PolyBase to access it directly, or you could access it, or you could use PolyBase to access it indirectly, or you could access it directly through MapReduce. And that really gives you a couple different ways to access your data, but it's still online and available for you. So to do that, you could create an external table, such as HDFS backhaul data archive, and then do a select statement from it. So you're doing a create external table as select. And you can see that here, where I'm archiving all the data less than the year 2000, for example. So I'm really archiving some old data out into Hadoop, and this will archive it for me very quickly. So now we've talked about how to bring some data into PDW. We've talked about how to take some data out of PDW from Hadoop. Also, you can join data on the fly. So you have data sitting in, now we kind of have this mixture of environments. You have some of your staging data sitting in Hadoop, some of your current data sitting in PDW, some of your old data sitting in Hadoop. What can you do with it? Well, PolyBase makes it easy to join all that data on the fly. So that means now all your dimensional data on PDW, you might have some of your current fact data sitting on PDW also, some of your older fact data sitting on Hadoop. And with the right views and the right queries, we can join all that data on the fly to really bring it back together for the end users. What that really starts looking like is, well, it's no different than what you do today. So I've moved some data off. Let's say I have my fact sales table sitting off in Hadoop, and I have dim customer and dim date sitting right there in PDW. It doesn't matter to me. I can still write this query just like I would any other query if I defined that fact sales table. Or what might be even more interesting is fact sales may be a view over some data sitting in PDW, my fact sales table. Also, some data sitting in Hadoop, maybe my fact sales archive table. And then I have a view called fact sales. My end users who are querying it, that are sitting there working in, my business analysts, they don't need to know any of that. All they need to know is they just need to access fact sales. And we can really deal with the underlying, where does the data sit, whether or not it's in PDW or Hadoop. We can deal with that through views and provide those views to them so that they can get it. All right, so that leaves me about 5 minutes for a quick demo to really kind of bring some of those concepts together. And so what I'm going to do here is I have a PDW and Hadoop environment, and what we have here is really the idea that we want to kind of do that. We want to take the data that we have sitting out there and really kind of move that data through a typical life cycle. So the idea here is I'm going to start off with creating a working table, and it's just fact internet sales past PAC. And what we're going to do here is bring some data into it where the order data is greater or less than 2004-11. So we have a set of data sitting in this new table that we're going to use, and it's sitting here right in PDW. What we're going to do now is we also want to create a fact internet sale archive table. In this fact internet sale archive table, if you go look at all the data, this is just a typical table, and it's going to sit in our PDW appliance, okay? So this is another PDW table I'm creating, and it has no data in it. We're just creating it, and it's sitting there. So the first thing we want to do is we want to, in our typical life cycle, I only have data less than 2004-11 in my fact table, but I have data sitting out in Hadoop that I can bring in, and it's sitting out there in my factored in sales external stage table. And what I can do here is I can create a stage table in PDW with my newer data. So now I've brought data in. I have a lot of data sitting out in my staging table. I now, I'm running my normal process, and what I want to do is I want to bring in the newer data into my staging table. Why aren't I bringing it into my fact internet sales past BAC table, my final table? Well, because I never bring fact data in directly to my fact table. I always bring it into a staging table, and I partition switch it in. It's by far the most efficient way to move large amounts of data in a data warehousing environment. So I create this table. What this does is this is a CTAS statement bringing data in to PDW from Hadoop. And it's just a straightforward SQL query. So now I have data sitting in my staging table, I have some data sitting in my fact table, and I have an empty archive table sitting there in PDW. What this allows us to do now is we can, first of all, we can move data from stage to our fact table, and I'm just doing a quick partition switch. So I can move that data straight into my fact table, and now what I should have is, if I do a count from all three of these tables, you'll see that I have lots of data sitting in my fact table, I have no data sitting in my archive table, and I have no data in my staging table. And so what that allows me to do now is I can now archive out my oldest partition of data that has data in it out into factored in net sales archive, because it has the exact same structure as my factored in net sales table. You'll now see that I have a little less data sitting in my fact table. I have a little bit of data sitting in my archive table. And now what I can do is I can create an external table out in Hadoop, and I give it a specific location that is based off my fact internet sales archive table. And now I've taken that data sitting in PDW, I've moved it out to Hadoop, and now I can drop my working tables, which are the archive table and the stage table sitting in PDW, and so that I can even query the data sitting out in my archive table if I wanted to. That's all the data that's sitting out in Hadoop, and I can access that through my external table. And now for my end users, what I can do is I can create a view. I can create that view that's sitting there over my fact table sitting in PDW, over my archive table sitting in Hadoop, so that I can now do a select count from the two environments. And that comes back. And so that now I have the ability to really just query that all of my data through factored in net sales 24 paths. Over here to the left, if you look at PDW, what you'll see is we can see some of the remnants of the stuff I'm talking about. Down here at the bottom, we have these external resources. We have things such as data sources, and you can see I have a couple different data sources in here. So that's defining two different Hadoop environments. One of them is a HDInsight environment, and the other one looks like an Azure environment, so an Azure block storage environment. And then down below, you see file formats. You see there's different delimited formats of different types, like pipe delimited and tab delimited. So we can make different file formats. We can have different data sources, so that as I'm defining my external tables, like I did up here above, I just need to define the location on that data source, the file format that I have, and so we can have multiple different file formats sitting out there. And what we're really doing is we're doing that scheme on read as necessary. So once I've defined all those, then I have my normal PDW table sitting here over to the left, and then I also have this area called external tables. And if I open this up and refresh it, you'll see my external tables that I've defined. In fact, here's the one which is factored in net sales external archive 2001. And I can open that up, and I can see the definition of the table that I created out there in Hadoop, and it's sitting out there for me. And if I go out to Hadoop and take a look, did I lose that one? Yeah, I did. If I go out to Hadoop and take a look at it, I can, there it is. I can take a look at it, and I can see, if you take a look at my Hadoop FS, I can see the different tables that I have sitting out there in Hadoop. And in fact, if I go look at this environment again, you should see a new table that just got created, which is the factored in net sales archive table, which is sitting, that didn't belong there before. And in fact, if I go look at that really quickly, there's 2001. And if I look at that, you'll see that there are 16 files there. So when I did that create external table, I was doing that from a PDW appliance that has two nodes in it. So that means there's 16 distributions. So when I create an external table, each one of those distributions creates a file underneath this folder for those distributions. So this is where you can see the parallelism that's happening without me having to do anything. I don't have to think about the parallelism. PolyBase and PDW, it all takes care of it for me. So that's 16 pieces of data movement. That's how we're able to move so much data so quickly. So when you're starting to talk about gigabytes and hundreds of gigabytes and even terabytes of data that need to be moved, and you're talking about 200 or 300 connections, now you can see that over InfiniBand or a 10 gigabyte connection, you really can move a vast amount of data pretty quickly because there's a lot of different moving pieces and parts. It's not all going through one bottleneck of, let's say, one SSIS package with just one data flow. This is really a true parallel data movement, and that's how we're able to get a lot of the performance that we talk about. So at the end of the day, we'll go back to the slide deck. Of course. There we go. All right, so that's our demo. So at the end of the day, what that really allows us to do is really allows us to think of PDW as being part of a bigger system. And that is that you have PDW sitting there, but it's really the modern data warehouse as we start looking forward, as we have more data, we have different types of data, is really larger than just our data warehouse. We really want to be able to extend it out and make it seamless to the end user. Yes, you could do a lot of this stuff without PolyBase, but then you have to have people that have the ability to be able to do MapReduce, people to be able to do Pig, people to be able to do Hive. You need to be able to run programs, and you have to retrain a lot of people. And your end users, it may not be as seamless to the end users, or in order to make it as seamless to the end users as you want it to be, there's a lot of operational stuff that needs to go on underneath. But the great thing about an appliance and something like PDW, where you already have massive parallelism in the PDW region within the APS system, is that now with PolyBase, it really extends that simplicity out to Hadoop, so that we can really mask a lot of that stuff from our end users without having to learn a lot of new tools ourselves, and really reuse the skill sets we've spent the last several decades for many of us developing, and just continue using those skill sets and really just kind of mask the, it's like a lot of the rest of the internet as, as it gets much easier for the end user to use, there's a lot more complication going on under the hood. And this is a place where we're really trying to mask that complication for people and really just kind of extend those data warehouses out into multiple regions in multiple places and put data where it belongs correctly so that we can really be efficient. And then where we are right now, looks like we have about 10 minutes, so we can take a few questions if there are any left.
Thanks, Brian. It's a fantastic session. We do have some questions. So the first one up is from Roman. I'll not try and pronounce his name, but he's saying, will APS be available as a service on something like Azure at some point in the future? More of a roadmap question, but you might be able to answer that.
Yeah, so I can't answer that. I don't know the answer to it. That's a question that comes up a lot. This is a company, Microsoft is a company that is cloud first, mobile first. So you can imagine that in some point that would be a possibility, but at the present there has been no announcements or any plans that I know of to do such a thing.
Yeah, I imagine it must be quite tricky, considering that the one of the keys to the APS appliance is the InfiniBand network providing ridiculously fast
and there is a ridiculously fast. Yeah, there is a ridiculously fast network up in in the Azure data centers and everything. Where we're really seeing the demand for people that want to do data warehouses and they have a lot of data, that demand is currently on-prem. I'm sure as you can imagine, if that demand changes, if the winds start blowing in a different direction, I could see where that would make sense. But currently there are no plans that I know of.
Yeah. Now there's actually 3 questions that are almost on the same thing, so I'm going to read out all 3. Matt Penny says, sorry, really basic question, how do you install PolyBase? But at the same time, Diana Tsheva asks, can PolyBase be used with the SQL Server installed on a regular standalone server, i.e. not using PDW at all? And Hugh asks, so PolyBase is just part of PDW appliance, and is there any plans to have it independent as part of the SQL Server stack so I can query Hadoop via PolyBase from the normal DB engine? So you can see they're all kind of the same question about, you know, how
those are fair questions, and usually when I have time, I probably do a little bit more setting up to make it very clear what PolyBase is and isn't, and setting up that this presentation is kind of assuming you already have some basic PDW knowledge. So the questions are, PolyBase only comes with PDW. PDW only comes with the appliance. And so, no, PolyBase does not come with SQL Server, and there are no current plans to include PolyBase with standard SQL Server. PolyBase is a feature of PDW. And once you start seeing the parallelism that I was talking about, you can understand why PolyBase really works with PDW in a way that I'm not sure it would make as much sense with SQL Server. In other words, we're talking about highly parallelized queries between distributions and nodes within Hadoop. So currently, PolyBase is only part of the PDW appliance. How do you install it? If you have PDW version 2, you have PolyBase, and it's ready to go. There's a couple things you need to do to set it up to get it really kind of running, including I kind of talk about it, defining those external sources. But if you have PDW, you have PolyBase, and you get to it. Did that answer all three?
Yeah, I think so, and which so yeah, the whole thing of being able to say, because PolyBase just comes as part of PDW, and so when you get the appliance installed by the Microsoft or the vendor who comes and does that, then it's installed for you. So I think that is covered sufficiently well. And so on that, we're actually out of questions, and we have a good few minutes to spare. But I think, having said that, I think there's we do have some more appearing. We have let me have a look at this. Diana is saying, so how can you practice PolyBase then?
So the question is, how can you practice PolyBase? That's a really good question, and those of us in the field, you have to have a PDW appliance. What it comes down to it is you have to have access to PDW. Is the only way to play with these kind of tools. And PDW, because it is an appliance, because it is designed to solve a particular problem of a massively scalable data warehouse, isn't sitting out there for a lot of people to use. And so one way to work with it is if you have a partner in your region which works with PDW. Sometimes they have access to PDW appliances in which you can work with them, but even then they're fairly limited on their ability to, it depends on the partner and what have you. But getting access to PDW, unless you're a company that owns one, has been problematic for pretty much everybody.
Fantastic. And finally, Hugh comments on saying. He says is a quarter rack the smallest correct for APS, but I think he means a single scale unit. We don't use the quarter rack terminology.
Yes.
Of course.
So the answer is yes. We call it a quarter rack or a single scale unit. On HP, it's two nodes. On Dell, it's 3 nodes. That's the smallest we can get. So that would include 16 or 24 distributions on those two.
And so then he says, so what kind of cost is that? Or is that very much an it depends?
I would say talk to your local sales team. I'm in consulting. I don't know the exact costs of these, and of course it depends on who you talk to and which vendor you go to and what kind of discounts you can get, what's your relationship with them. I couldn't answer that. Be disingenuous of me to give you a number.
I do find the same with that. A lot of people ask me how much PDW costs, and I try and avoid it. The way that I try and compare it is that it's comparable with the 32 core Enterprise Edition of SQL. So by the time you're talking about the kind of space that you would need 32 cores, then actually you could be seriously considering PW.
I mean, the way I talk about it is opportunity cost. Let's say you didn't buy PW and you wanted, let's say you had a 10 terabyte system or a 50 terabyte system you wanted to build yourself. If you go out and, first of all, buy that 32 core system and buy Enterprise Edition, and you start thinking about, okay, what else do I need to do? Okay, I bought the hardware. Well, I figured out what hardware I needed to buy, and I figured out how much memory I needed to have. I now need to go buy a SAN or allocate SAN space to do that also. And now I need a SAN engineer to do all of that for me. I also need the networking people to really make sure that's all taken care of. I now have the server. I have to install it. I now have to spend a few weeks configuring it probably. And I also have to test out the SAN, the disk space, and kind of test out, hey, are all the disks ready to go? Are we getting the kind of I/O that we expect for SQL Server? Now that I have all of that, now I have to design my database and put that on there and really start moving all the data. Literally from soup to nuts, opportunity cost for building a large-scale data warehouse can take you, for most people, anywhere from 3 to 9 months to do. And in those 3 to 9 months, you have a lot of people making decent money working on all those projects to get it set up and ready to go. And when you start talking about SAN space and 32 core machines or like HP DL 980s or whatever you're going to build it on, you're not talking cheap things either. So at the end of the day, when we start throwing out numbers for PDW and they sound large, the reality is they're not any different, or they're not much different than what it would cost you to build it yourself. In fact, they're probably, from an opportunity cost standpoint, much cheaper because once that thing arrives, I've literally been at multiple customers where that PDW has been shipped, it's landed, it's been connected by Microsoft and the vendor, and literally that same day, we are creating databases and moving data. I've had that happen multiple times. So there is an opportunity cost that's lost there. So when you really start talking about the complete value of the system, you start understanding that just throwing a number out there is really disingenuous. There's really a lot more to talk about there. And on top of that, if you build it yourself, you don't have tools like PolyBase, for example, that you would have available to you.
Yeah, I love the fact that the scale-out question is just solved with PW, and any other way of doing it, it's really not. But anyway, it's almost the hour, so I want to thank you again, Brian, for speaking on this last session. I have no idea what time it is where you are, but I imagine that it's late or early or.
Yeah, thank you.
I want to thank the 40 or so people that joined for this final session. It's always hard to know how many are going to attend when America is asleep, and it's been great to see such fantastic attendance for all the sessions that have been part of this great event. We will have another 24 hours of pass in September, 8 weeks out from the Pass Summit. So please join us again for that. And yeah, remember to talk to your chapter leader this week about getting a code to get you a discount on the Pass Summit. Thanks again, Brian, and thanks to Pass for everything that you've done today, and of course the rest of the year. And we'll see you all in Seattle. Thanks, everyone.